Okay, so the handout there says this section is about composition functions and function operations. We're going to start with function operations. When you're talking about operations in math, what comes to mind? Order of operations, what did you say? Same thing? So order of operations, more basic than even the order of operations. Think back to elementary school. So PEMDAS, that's order of operations. So what's within the order of operations? There you go. So those four. And there's more in the order of operations, but those four, that's what we're going to talk about when we talk about function operations. This part's not written on that handout. We don't need to write it down. Oh, it helps if I turn this on, doesn't it? So this part's not written on the handout. We don't need to write it down because it's very basic. So when we deal with addition, there's going to be an addition sign in between the functions. Subtraction, a subtraction sign. Multiplication, they're going to use a little dot. Well, we know that. For division, they're going to set it up as a fraction. We've seen that over and over again. So I didn't think we needed to write that down because it's very straightforward. So this is where we get into the handout. What we do have to be careful of when we're looking at the book or when we're looking at a worksheet tomorrow or the day or when we come back from spring break is we have to make sure we're paying attention to the directions that fit the problems. What's going to happen, particularly in the book, is there's going to be different sets, and you want to make sure you're looking at the equations that fit that set. If you're on a problem down here, and you accidentally look on the equations that are up here, you're going to get the problem wrong. You need to look at the equations that match this problem. So you want to make sure you're looking at the right equations that match the problem you're on. All right, so here are the two functions I'm using for this first set of problems. First problem, I've got g of x plus f of x. That's what I have written out. That will be what they give you on the homework. I expect you to write that out. What do you think you do next? Plug them in. I think we could have done this even if I didn't teach you how to do it. It's pretty straightforward. We're going to plug it in. So we're going to take the g of x. Whoops, we're going to take this one first. So we're going to take 9x to the 1/2. Plug it in for g of x. Then they want me to add f of x. Well, f of x, they're telling me, is 4x to the 1/2. So I'm going to plug that one in. Well, then I just need to decide if I can add those. Sometimes I'm going to be able to, sometimes I'm not. So I have to remember like terms. And we'll write this off to the side in the margin in a minute. Remember, like terms are the same variables with the same exponents. Well, those have the same variables. They have the same exponents. They're like terms. So I add I add the coefficients, 13. Here's what we need to remember. Do I keep the exponents or add the exponents? Keep the exponents. Good, Colby. So it's 13x to the 1/2. So maybe off to the side, maybe you do it on the margin here. You might want to remind yourselves that to add or subtract, and maybe you don't need it, maybe you don't have to write this down. That's up to you. You have to have like terms, which means the same variables with the same exponents. And when you add them, you keep the exponents. And the reason I add that part about keeping the exponents is what we just did in the last section is we had all these other properties where we were changing the exponents. Sometimes we were adding the exponents, sometimes we were multiplying the exponents. Well, here, when we're adding and subtracting terms, we have to remember we keep the exponents the same. And then we'll go on and we'll do the second one. we're going to do f of x minus g of x. So again, I plug in. And again, on your homework, you're going to put this part down. You're going to put f of x minus g of x. Don't plug in right away. Write the problem down. So write down f of x minus g of x. I already wrote that for you. So you do f of x first, 4x to the 1/2, minus g of x, so minus 9x to the 1/2. They're still like terms, so I can subtract them. 4 minus 9, that's negative 5, x to the 1/2. Now, number 3, I should be able to answer without plugging in. We are going to go through the steps of plugging in, but we should know the answer. If I'm going to do f of x minus f of x, what should my answer be? 0. I still want you to plug in, though, for this assignment. So I'm going to plug in 4x to the 1/2 minus 4x to the 1/2. And yes, if I subtract those, I'm going to get 0. Some people will put 0x to the 1/2. If you put that, okay. But really, we should just be putting 0 as our final answer. Now, I'm going to move on to that second section. This is where I want to make sure I'm using this new set of equations. Don't accidentally go up and use that set we just used. How are these equations different? So the exponents aren't the same. How else? How are these equations different than the equations we just used in the set above? They're binomials. They're longer. So we have to be a little more careful when we plug them in. What do you think I mean by that? I have to do something when I'm plugging in. What, Jared? Something with the signs. I have to do something when I plug them in. I can't just throw them down there. Because there's more than one term, I have to do something else. I usually do this when I plug in, but I've been lazy on those other ones. Usually when I plug in numbers, I make a big deal and I say, oh, I'm going to plug in and I have to use parentheses. If it's more than one term, I got to make sure I go back to my skills. I got to go back to being really detail-oriented. I have to go back to using parentheses. Otherwise, it's the same. So we're going to do f of x. So we're going to plug in parenthesis 2x to the 2/3 minus x to the 1/4. Close the parenthesis. I'm going to add g of x, which is negative 3x to the 2/3 plus 5x to the 1/4. Now, we saw this in the last chapter. The difference was we saw this with just integer exponents. And with integer exponents, we also made a big deal about putting it in standard form. With standard form, what has to come first? The largest exponent. The good news is I'm not going to make a big deal about that with the fraction ones. We should be able to do it, but if you slip and it's not in standard form, it's not a big deal. The other thing we saw in the last chapter was, okay, if it's addition, what's really in front of each of those parentheses? A 1. So if I distribute 1, it doesn't change anything. If this is addition, if I accidentally forgot the parentheses, it's not a big deal. So I can actually go ahead and just combine like terms. So I'm going to combine the 2 and 2 x to the 2/3 and the negative 3 x to the 2/3. Those are like terms. So I'm going to get negative x to the 2/3, or some of us might write negative 1 x to the 2/3. I'm going to combine negative x to the 1/4 and 5x to the 1/4 to get positive 4x to the 1/4. And if not everything matched up, we just go ahead and combine them. Kyle French, you with me here? That's my answer. Again, if you accidentally put that in a different order, that's okay. All right, let's look at the subtraction one. F of x minus g of x. So f of x, put it in parentheses, 2x to the 2/3 minus x to the 1/4. Then we're going to subtract negative 3x to the 2/3 plus 5x to the 1/4. Well, Andrew, what do you think I have to do here?
Distribute the negative 1.
Yeah, here I do have to distribute. Again, we saw this in the last chapter. And in the last chapter, same will be true here. You can show me that distributing within the problem, like that. I just changed all the signs of the second one. Some of you don't like that. Some of you show it on a new line. So I'll show that way here. You keep the first one. Maybe you'll lose the parentheses. And then I'm going to distribute that negative through to make it positive 3x to the 2/3 and negative 5x to the 1/4 if you like to rewrite it. As long as I see it one of those places, that's fine. And now combine like terms. So I've got 2x to the 2/3 and 3x to the 2/3. That would be 5x to the 2/3. I've got negative 1x to the 1/4 and negative 5x to the 1/4. That would be negative 6x to the 1/4. All right, go ahead and do that next one on your own. G of x plus g of x. You're going to find that sometimes you use the same equation within a problem. So you're just going to take the red one and add it to itself. Do g of x plus g of x. On the board up there, it's the red one plus itself. G of x plus g of x. So I filled in my equations. I didn't have to distribute because this was addition. Rachel, what'd you get?
Negative 6x 2/3 plus 10x and 1/4.
Yeah, I agree. So negative 3 and negative 3 gave me negative 6x to the 2/3, and 5 give me 5x to the 1/4. All right, let's move on to the multiplication. So Gracie, we're about the third section down. You see where we're at? Okay. All right, so we've got now f of x is 6x, g of x is 3x to the 3/4, and h of x is 9x to the 1/5. Same idea. For number one, we've got f of x times g of x. We're going to plug in. So we're going to plug in f of x, which is 6x, g of x, which is 3x to the 3/4. You have options here. You can keep the dot like they do. When I actually go to plug in the functions, I like to use parentheses, but it's your choice, personal preference. So you can keep the dot like they do when they use the function notation. I move on and I use parentheses. Well, now this actually is a little bit more like what you did in the last section, except good news, it's with the variables. So it's the ones that most of you found a little bit easier. You're not using the table on anything. It's the properties of exponents. So when I look at this, I am allowed to multiply those. I multiply the 6 and the 3, 18. Carly, do you remember what I do with the exponents? I add those. So in our calculators, let's do 1 plus 3/4. Tell me what you get.
7/4.
7/4. So that's my answer. 18 x to the 7/4. That's not bad. Let's do the next one. G of x times h of x. So g of x, 3x to the 3/4. Again, I like to use those parentheses. H of x, 9x to the 1/5. We multiply the 3 and the 9, 27. Multiplying, we're adding the exponents. So in our calculators, we're doing 3/4 plus 1/5. Tell me what you get.
19/20.
People agree with Robert? Okay. Sounds a little familiar to me from this morning. So 27 and then x to the 19/20. Again, the good news is this was with variables. So I don't have to go to my table. I'm not simplifying anything. These are just, do you remember your properties of exponents? If it's multiplication, you add your exponents. And we move on to division. So you're still on that same thing across. This is number 3. We've got f of x divided by g of x. So f of x, I plug in 6x. G of x, I've got 3x to the 3/4. Well, I divide the 6 and the 3, 2. Kyle Rubio, you remember what I do with the x's?
You subtract.
I subtract. So division, we subtract the variables. So in our calculators, let's do 1 minus 3/4. Some of us might not need it.
1/4.
1/4. And it's positive, so I put it on the top. So 2x to the 1/4. And then the next one, g of x. So I'm going to plug in 3x to the 3/4. H of x, 9x to the 1/5. So I'm going to divide 3/9, or they didn't like how I said it this morning, so maybe I say I reduce those. They're both divisible by 3, so that's 1/3. Now I'm going to subtract 3/4 minus 1/5. I don't remember what we get.
11/20.
So it's positive, so x to the 11/20 on the top. And you can have that 1 up there with it, you don't need it. So x to the 11/20 over 3. I want to add one more. So maybe if you didn't write too big, maybe underneath, or maybe if you have some room off to the margin, somewhere try and add a number 5 in here. Because I should have added this example. Let's do g of x divided by f of x. So we're going to flip-flop that number 3. G of x divided by f of x. So we're going to do 3x to the 3/4 divided by 6x. So I'm going to reduce 3 over 6. It's 1/2. What happens when I subtract?
You get a negative.
I get a negative. Or I'm subtracting and I think it goes on the bottom. However I think of that, because in here we think of it different ways, but my answer is going to end up on the bottom. It's 1/4. So I get x to the 1/4 on the bottom with that 2. This is what I wanted to remind you of. We said We're not supposed to have that fraction exponent in the denominator. But for whatever reason, mathematicians have said, if the fraction exponent's with a variable, they're okay with it. So we're okay with that answer. For whatever reason, if it was 5 to the 1/4, they're not okay with it. I don't know why. It makes no sense. But I'm not going to argue. We decided we're not going to argue because we don't want to have to mess with that. So if you get this kind of answer today or tomorrow, be okay with it and stop there. Okay? I don't think you're going to get any of those today, but just in case, I wanted to throw that one on your handout. Okay, now we're going to move to what's really new. This is not really new. I think you probably could have handled this kind of stuff without a lot of instruction. But these composition functions are something you've never seen before, at least I don't think. So a composition function, this is something we're also going to have to get used to how to read. And so what's going to happen is we're going to do it today, we're going to do it tomorrow, you're going to totally forget about it. So we're really going to have to learn about it again after we come back from spring break. So the way we read it, I put it underneath there as well. We read it g of f of x. Every time we see one of these parentheses, we say the word of. So like this right here, I say g of f of 3. Or if I write something like this, I say f of g of 2. And I don't say anything for those parentheses behind it. Or if I have this, I say h of g of 7. And I know we're going to have to practice that. We're not going to say it right away, and that's okay. We're certainly not going to say it right after spring break, but it's going to take some practice. So then this example I kind of wrote across. So I have these two functions, and then I have this example. And I kind of color-coded it up here again, because this is how we're going to break it apart. We're going to take this red part and kind of then go back over to the left side, and let's put f of 3 back underneath where it says example. So go back over to your left side and put f of 3. Because let's just say I asked you to do f of 3. We should be able to do that. I've asked you to do that before. I asked you to do that in the last chapter. Does anyone remember what f of 3 means? What I'm asking you to do? Colby? Yeah, where?
For the F.
In the f function. So that's why it's a little bit more important that I have the f and the g in these problems, because now I have two functions. When we did it in the last chapter, we just had one function. But now I'm giving you all kinds of functions. Think about these problems, we had 3. So the f is important because it's telling us to use this one. The 3 is telling us the 3 is going to go in this spot as well as this spot. So next to this, we're going to say it's equal to 2, plug in the 3, and then minus 7. So this notation is telling us we're going to take 3 and we're going to plug it in for x. We're using direct substitution. We also use that notation to do synthetic, but we've moved on from synthetic right now. So 2 times 3 is 6, minus 7, negative 1. Okay, so we know what f of 3 is. Well, go back to where I have this written out. If I know f of 3, cross it off. F of 3 is negative 1. So I'm crossing that off, and I know it's negative 1. Oh, look what I've written now instead. I've written g of negative 1. So go back, and if you have room underneath this, put it underneath or put it somewhere in that area. Now I've got g of negative 1. So now what that's telling me to do is to go to the g function. And in the g function, we're going to plug in negative 1. Well, and I better use those parentheses I was harping on earlier. So negative 1 in parentheses squared plus 4. Since it's in parentheses, when I square it, it's positive 1 plus 4 is 5. So what that means is that g of f of 3, the whole thing, is equal to 5. So what these problems are they're really a plug into one function, take that number, plug it into another one. It's a little confusing at first, but once we do a couple of them, it's going to go a little bit quicker and a little bit quicker and a little bit quicker. So we've got 3 functions down there below, and we're going to do 3 of these. Do I have questions on this one first, though? People have it. Okay. And I'll make sure I show you what all I expect to see. So this first one, we've got f of g of 5. So f of g of 5. So we moved on. We've got the functions we're using on the top. We're not using those example functions anymore. So I want to start off with the inner part. So I want to see what you're doing. You're going to label your work. So we're doing g of 5. So you're going to show me that. So you're going to write g of 5 equals. That's telling you to go to the g equation. So that's telling you to do 2 times 5 squared. Put that in your calculator. Some of you will do it in your head. So we need 2 times 5 squared. Tell me what you get. 50, I would agree. Because it's 5 squared times 2, so it's 50. You work your way out. So now the 50 is going to get plugged into f. So then you're going to do f of 50. You're going to show me that label. Part of what you're getting credit for is that label. So f of 50, that tells you to take 50 and plug it into the f equation. So f of 50 minus 8. Plug that into your calculator. Do it in your head, whatever you're comfortable with. Yep. Now, on the last problem, I rewrote this. So on the last problem, I rewrote f of g of 5, 142. You don't have to rewrite it every time. Just circle that last number. So you don't have to rewrite your answer, because you'll have your original problem up here. So you don't need this part. I'm going to skip 2 for a minute because I want you to try 2 on your own. But I want to get another one under our belt together, and 3 is a little bit trickier. So I don't want you to have to try that on your own. Let's try 3 together. We've got g of h of 2. Which function should I use first, the g or the h? The h. We start on the inside. So we're going to do h of 2. So we're going to do 2 times 2 to the negative third. Negative exponent. What's going to happen with a negative exponent? We're going to get a decimal, but we know how I feel about decimals. Let's make it a fraction. So yes, your calculator gives you a decimal because that negative flips it. So let's make sure we turn it into a fraction. So tell me what fraction you get. I would agree with 1/4. So we started on the inside. We're going to take that number and work to the outside. So now we're going to do g of 1/4. So that's going to get plugged into that red equation. And this was why it was a little trickier, because you had that fraction you were going to work with. So we're going to do 2 times 1/4 squared. I think you're still going to get a fraction. 1/8 sounds right. And so I circle 1/8. Once you have that, give number 2 a try on your own. How French are you lost? Do you see where we're at? All right, so the first thing you should have done is you should have done f of 5, so I went ahead and set it up. Carly, what'd you get for f of 5?
7.
I agree with 7. So then, Justin, where'd you plug that in?
G of 7.
I would have done that, so g of 7. I'm not gonna change colors here. Justin, what'd you get?
98.
I would agree with 98. So our final answer is 98. All right, flip it over. We're not going to do all of the back. We're just going to do one because really I'm not going to give you problems like what are on the back here until after break. But I want us to just look at one so you can start to see what's going to be coming. So I want to do this first one in the top section there. So how is that different than what we just saw?
There's value not some number.
There's no number, it's x. So when I look at this, f of g of x, I think, oh, I want to take x and I want to plug it in to g. Well, if I want it's already there. That doesn't make sense. So then I'm going to take g and I'm going to plug it into f. What that's saying is I'm going to take this whole thing and I'm going to plug it in to that equation. So here's what I want you to do on your paper on that number 1. Is that outside?
Oh,
Back
that's the
there.
room.
So we're going to take this, this is interesting, and we're going to plug it in to that equation. And let's even circle this and draw an arrow to that x. So we're taking g and plugging it into the f. So we're going to keep the 2, because that's part of the f equation. But where I see the x, we're going to plug in g. So we're going to plug in 4x plus 1. Do I need anything else? I need the minus 3. Good. And we're just going to work on simplifying. I feel like it's like out here. Now what do I need to do?
Distribute.
Yeah, so distribute the 2. And then what?
Take 2 minus 3.
And then, so you're right, combine like terms. So we're going to get 8x plus 2 minus 3. And so 8x minus 1. Again, we won't see those in our homework until after spring break. The ones in your homework that are function notation or composition functions are going to have numbers in there. All right, your homework, I'll put it right here, is page 432. Numbers 3 through 27 odd. Make sure you do the odd. And then the plan tomorrow, just so you know, is we'll go over homework, obviously. We may do 1 or 2 examples. My guess is we won't need it. I'm going to give you a worksheet to do in class, but it will be an in-class worksheet. You'll turn it in before you leave, so there will not be homework over break. So don't worry about having homework over spring break. We won't be learning anything new. We only have about 5 minutes. If you want to start, you can. If you don't want to get your stuff out and you don't want to start, you do not have to.